Hello, everyone. My name is Marco Salino, and welcome to the Hackathon here. And thanks for attending this presentation. We're going to talk about the challenges of working with in AEC. So, as I said, my name is Marco. I am the visualization product manager for Techsoft 3D. I've been in the company just over 2 years, and before that, I was with Bentley Systems for about 8, where I was a product manager for microstation and 3D modeling, interchange, beam automation workflows, and visualization. So, brief introduction of the company. Who we are. Techsoft 3D is one of the leading SDK providers for 3D engineering applications. So we don't sell or make end user solution, but we help companies to build their own end solution for engineering, to address engineering problems. It was founded in 1996 by software engineers. Most of our employees, our colleagues, are still software engineers, over half of that. Many more are engineers of some sort, like me, at least as a background. We now employ about 120 people all over the world. Our mission is to fuel innovation with unmatched 3D technology. We really, really like what we do. We take a lot of satisfaction to see what our partners can build, also thanks to our technology and our products. So we have about 700 partners, I would say, right now. Of course, some are in the AEC. You will see some of the well-known logo here on the slide. But we span, we don't focus on AEC. It's not just our main target. We span all industries, simulation, PLM, manufacturing, you name it, and we pretty much are present. I remember when I was hired, Ron, our CEO, telling me, when you walk around the street of Dublin, that's where I live, look around, and pretty much everything you see, there's a very good chance we were involved in the design or the build of that thing. And I think it is pretty much true. So we are living in a, when you want to build a successful engineering application, I think it's key, we think it's key to make sure all the components and the tools are well integrated together. So you might have the best importer you can think of, but if your graphic engine or your modeling kernels aren't good enough or up to the same level, your results are not going to be good. The other way around, if you have a fantastic graphic engine, but the tessellation, the data you feed into it is not great, again, you're not going to really get the maximum benefit out of your graphics. So we believe we sell the most comprehensive suite of SDK. So we have everything we cover: data import, visualization with multiple products, modeling, simulation, and of course, publishing as well. So let's just talk about what we face when we work with AEC. My point of view is more for maybe building application, but I try to also remember when I worked in AEC for about 12 years before, what are the challenges. So one is definitely the data integration, and pretty supported by the other talks I've listened to this morning, right? It's a massive problem. The teams are getting larger. We have now digital twins. We can make projects at a much bigger scale. We need collaboration. And people are using different applications in different disciplines, and we need to bring all this together, and it's not always simple. The size of the data is also growing, the complexity as well, not just because of the massive projects we're working on, but just for the nature of the data. And we also then need to visualize and interact with this data at some stage. Once we solve the first two problems, then we have to do something as humans. We still have to look at the data and do something with it. And I think another challenge we have is the field adoption, right? I think there is still a gap from how much we use this data, these beam frameworks in the design phase that's really well developed now. But then when we go past that first step of the life cycle of any assets, it's, I think there's a gap in adoption. So multiple data types and forms. So yeah, we have a lot of different data now. We talk of just a simple beam project. We're going to have multiple teams working on different disciplines, different applications. I remember talking with some of the UK firms years ago, and they didn't really care what people want, their employees or architects wanted to use. They would just give them any license that they wanted, because the cost of training them and forcing them to use an application wasn't viable. So they would just invest the money and the time in building complex systems to bring all this data together. And Arup this morning gave a pretty good example of what the problem is. And the data is not just different, coming from different applications. We got different nature. We got physical data, point clouds, and reality meshes, which are coming in together. And I think it's a much bigger challenge than years ago when we were starting to work with 2D drawings and then some 3D. So now it is definitely a challenge. This hasn't been resolved completely. So what we need is ways to integrate all this data together, but those systems have to go beyond just converting files from one format to the other, right? So we need to be able to bring all this data together and provide access to this data. We have a tool for this. It's called the OOPS Exchange. You can read over 30 formats, but the key is we are not just translating it. We make it available for any application you want to build, be it on the cloud or native. You can pick the data, and it's not just geometry. It's everything you might want or need. If we look beyond, well, at least when I usually talk about BIM or construction, I tend to associate it with residential or commercial, but there is BIM for factories, for example, where we also have different formats that need to play a role, like MCAD. And all of these have to play together in many use cases. Then we have to talk about the size of the data. The data, it is getting larger. We got massive projects, there's more files. The data itself is getting richer. There are most of the BIM packages now, you have multiple representation for geometry, LODs, that bloats up or it makes the data larger itself. And then, I mean, now the graphics, it's only one part, one view of the data, right? Probably not even the most important. So we have a lot of metadata that we really have to take care of and to manage. Talking with people last night, it is a challenge, right? There's a feeling that there's a lot of data in an AEC file that we mightn't even need all of it, but we still have to read it and do something with it and be able to scale up and treat it. And then the data is also more complex. The structure is getting more and more complex. So what you need is a system that can really be optimized or provide an optimization from end to end. Here is a diagram of like our web-based visualization engine. As an example, it can apply to others and probably also from some desktop solution too. So you really need to optimize the conversion. We know that in many cases you might batch convert sometime of the week or every night, so there mightn't be necessarily a problem, but in some application you just need to push a file and you want to see it on your web application as fast as possible. So you need to have a really well-oiled system all the way through. You might not import even file at all. You might directly create your data through authoring API. These have to be efficient and well-designed, of course. And when the data is on the server, we need to most likely send it to a client for visualization, for collaboration, for querying it at least. That's very normal. So there's different ways we can do that, right? We can work on a monolithic file, maybe try to compress it and optimize the way it's sent to the client, or we can use streaming. We can get these monolithic files and break it down in smaller nodes and then manage how they show up on the screen. We can also use different ways for rendering. We can render on the client. You could render on the server if you prefer. So you'll be streaming frames pretty much to your clients. You might need to use these also for security, so your data pretty much stays on the server. It never really gets out of it, which can be also very important. Once the data is on the client, and of course, what I used to really think more as performance of the FPS on the screen can also be important. Again, we're talking about usually very large models that we have to deal with. And there's different ways where we can work on that. We can be smart of what we draw on screen. We can try to make use as much as possible of the technologies we have. When we talk about web visualization, there are some limitations from WebGL or WebAssembly. WebGPU will probably help us to overcome some of those, but we can work on the spatial partitioning, making sure that the scene tree is actually optimized as well. the scene graph is optimized for what we need to do. And we usually optimize everything for our engineering applications. And then we go to having to visualize and interact with the data. So as we help companies to build software, we find that we are really now having to cope with a different graphic representation, which for a graphic engine, it can be challenging. You might have B-reps, you got meshes, you have point clouds, and most of the times you might want to display them all together, right? And that's okay. We can do that, but then you also started to have some newer formats. Implicit modeling, maybe in AC it's still not super diffused, but in manufacturing it is getting tractions. So you could tessellate everything and have lots of triangles, but then you lose performance and you lose the benefits of having a definition of a model as an implicit model with a few lines of codes basically that generate your graphics. So being able to display all of them together, it is actually quite challenging. And then we move into the interaction. So we supply, well, our visualization engines come with all the basic operators, all the one that you normally need in an engineering application. So having them to work on different data types also is challenging. Again, if you want, just think of the measuring tool between two B-reps or 2 points on a B-reps and start to mix it up with point clouds or with implicit modeling or some other sorts of data. It just kind of make it quite difficult. So again, here is just a little video what we kind of do. There's different type of interaction we can think of. Now also with digital twins, we are starting to see more and more requests to being able to interact with the live data from sensors that might be coming up from the server. Again, we got, point clouds also are really kind of starting to increase also on web visualizations. And you might need to do operations like just normally cut sections and do all your kind of querying and analytics on a model. We don't really do dashboards, but they're very easy to implement also on our systems. And then there is the last challenge that we can think of is how can we increase field adoption, which is kind of the focus also of the challenge we sent last night, or how can we make BIM simpler? Why there is a gap between the design phase, the architects, the engineer, and then the workers that could leverage it on field and they don't do. So what could we do there? Well, we can use tools that kind of support all the different platforms of the architecture. So desktop, mobile, AR, VR, which seems to still kind of struggle a little bit, but also web. And then also we can try to lower the barrier of how this data is made available and meaningful to these people. Again, maybe we go back to that extraction and only make sure we send them the real data, what they need for a specific job. So this is it. So TechSoft 3D, please, if you want to visit us on our website, if you want to test any of our tools, if you are in the business of creating applications, it's very easy to go to the link and set up yourself for an evaluation. You got 60 days to evaluate any of our products. And if you need any help, you can come to Peter and I while we're here around. Okay, if you have any questions or answers, I'm here.